Hello, everybody. Um, just want to review the time-light problem and the problem with the time-light problem, in that everything is a fabrication to begin with, including light, including time, including distance, and it's all made possible the way we see it today, anyways, by the formation of matter, because it's matter that dilates the rate of time and the measure of distance. We should know that from the collision of black holes and gravitational waves that result. It's a detection of the dilation of time and distance. So what happens when you have dilation of time and distance? Of course, the big argument is that it's not very much. Well, it's not very much here, but if you took away the matter, it would be a considerable difference. And if you go where there is a lot of matter, there's a big difference too. So in this general area, yeah, speed of light is pretty much constant. I mean, it's not constant because there is a dilation of time and distance, so it's not exactly constant, but it's kind of constant. And then when you have gravitational lensing, that's a variation of the speed of light, and the bending of light, which is the same mechanism. It's the gravity, the amount of gravity in a particular location. So not only have we detected distance and time dilation, we can observe it when we see gravitational lensing, because they would say it's warping or distorting time and space, and in a sense, I suppose that's the case, but it's also changing the speed of light. Just like when you look through a lens, part of the glass that's thicker, the light travels slower, and the part of the glass that's thinner, the light travels faster. So this is what's happening when it's going through time and space. It's the amount of gravity that determines the speed of light. So actually, you could actually say all throughout space, the speed of light is changing its rate, because every time it goes near a gravitational well, it's going to slow down. And every time it's far away from a gravitational well, it'll go faster. This is what the math shows. This is what they hid, whether knowing and whether wanting it to be or not. Hello, Iger and Patrick Caricas. Hope everybody's doing well. But they hid or didn't talk about the variable speed of light because it's hidden not in the speed, because the speed is always 186,000 miles a second, or 300,000 kilometers per second. But the variable speed of light is hidden in the fact that there's a dilation of time, or the rate of time, and the measure of distance. I've given this illustration before, but if you're a skeptic of what I'm saying, you have to think about it and respond to this example where you put your hands far apart as you can, maybe put them a couple blocks away on one side and a couple blocks away on the other side, and you say 1,001. That's the speed, or that's the time it takes for light to travel from one hand to the other. Let's say in this scenario, maybe there's a lot of gravity or something, because it's not 186,000 miles. But just to understand what the problem is, put your hands far apart and say 1,001. Then you put your hands real close together and say 1,001. Now tell me which speed is faster for the photon to travel. The photon that travels when you say 1,001 at the normal speed where we are, at that rate, that's a faster speed. Then when you're with your hands close together and you say 1,001, you can see the photon going real slow between your two hands. So when you change the distance and the rate of time, you're changing the speed of light. It's really not complicated. But somehow they've kept it from people's, ability to reason or whatever. I don't know what they... But it's not complicated. It's really easy to understand. And it's a fact of relativity. Because otherwise you wouldn't get gravitational lensing. So you're doing a premiere right now, back in a little bit. Yeah, this is short unless somebody wants to jump in real quick. Just wanted to put that out there. A real explanation of the changing or the variable speed of light. Sure, it's the speed of light is constant in a frame of reference. But if you change the parameters of that frame of reference, say the rate of time and the measure of distance, which is what changes with near a gravitational well and away from a gravitational well, then you're going to change the speed of light. It's so easy to understand, and anybody with half a mind like me should be able to see that.